All right, so here we are, and we are looking at the standard economic model, and we are going to talk about the efficiency of demand. What characteristics of efficiency do we reach in the standard model when we talk about the consumer side of everything that we have going on here? All right, so in class, we brought up the question, what happens if you have 6 mugs of beer and you had to give them out to your consumers? So we're positing that 6 exist. They just are there. And we have a world where we have 4 different consumers with very defined demand schedules that are simple and linear and easy to deal with, and just 4 individuals. Who do we give the beers out to? How do we allocate them across our society? We want to do this so that we maximize the total value to society. We're assuming that we are trying to be benevolent in giving out the different mugs to everybody out there, and we want to make society as better off as we possibly can. How do we do this? All right, so this is the graph that we had in class. This shows the individual demand schedules and the market demand as a horizontal adding up of all those individual demand schedules. So we can see the market demand and the individual demand. And we know that we need to get to an overall total value of 13. That's what we got when we had 6 beer and we looked at the area underneath the market demand curve for a quantity of 6. But who do we allocate these out to? The value of 13 to society is assuming that we allocate them correctly. So from this setup, how are we going to allocate these out? Well, we could go through one by one and say, okay, I have 6 beers. Who do I give the first one out to? If I give it to Emmett, we can look at the value of 1 beer to Emmett, the first beer that he gets, because he doesn't have any currently. If we handed one out, he would get a value of 50 cents. We can look at other people and say, hey, is their value as high or higher than Emmett's? And we could give the first one to whoever values it the most, and then we could reassess thereafter. So we could go through this problem and it'd be kind of long and drawn out, but we could look at each individual. We look at Lucy and the value of the first beer to Lucy, it's $1.50. We look at Space Guy and Space Guy values the first one at $2.50. And finally, we look at Batman and we see that Batman has a value of $3.50 for the first beer. So if we're standing there and we have these 6 beers and we're benevolent and we're going to allocate these beers out to society, and our goal is to have the highest total value once we hand out these 6 beers, the first one we should hand out should go to Batman. It should be $3.50 of value added to our kind of net here by giving 1 out to Batman. But now we have a question. Who do we hand the second, third, fourth, fifth, and sixth out to? Right? So let's start at the second one. Who do we hand the second one out to? Well, we already know that Emmett's value, if we hand him 1, is going to be 50 cents. Lucy's is going to be $1.50. And Space Guy's is going to be $2.50. But is Batman still going to be $3.50? No. Because we have to, in economics, think on the margin, we are now at a new marginal analysis. Batman's value now is only $2.50 because he is now going to be receiving his second beer. The marginal value of the second beer is just $2.50. So now we have this kind of weird thing where we have a tie. The Space Guy and Batman both value the second beer that we are going to hand out at $2.50. And since we have a tie and we're going to be handing out more than just 2 of them, I say we just give it to both of them. So we actually hand out our second and third beers to Batman and Space Guy. So now we've handed out 3 of the mugs of beer that we had. We can see that we had to give it to Space Guy at this $2.50. And we also give it to Batman at $2.50. They're tied within this, so they're each going to receive the second and third beers, right? So they each get 1 more. So Batman moves up to a total of 2, and Space Guy moves up to a total of 1. But now we have to think, who do we give the 4th beer that we have, the 4 of the 6 that we have to give out? And here we run into a similar line of thinking where we have to think on the margin, because now Space Guy already has a mug, and Batman already has 2. And so we have to look at the marginal value of the second unit to Space Guy and the third unit to Batman. Both of those will have the same value. It'll be $1.50, which is exactly equal to Lucy's value of her first beer that she receives, which is $1.50. Emmett's value of his first beer is even lower at 50 cents. Well, who do we give the fourth beer out to? We have a three-way tie. Luckily, we have a fourth, fifth, and sixth beer to give out, which works just perfectly for us since we have this three-way tie. So we're going to give one more beer to Batman, one more beer to Space Guy, and the first beer that Lucy receives will be a part of this as well. So in the end, what do we end up with? We end up with Batman having 3 beers, Space Guy having 2, and Lucy having 1. Try to get an arrangement with a quantity of 6 that has more value than 3 to Batman, 2 to Space Guy, and 1 to Lucy. You can't do it. It can't be done. This is the highest value that we have possible to us, right? This is the highest we can get. This is the most total value we can achieve. Leads into this market demand graph. And really what we should have is a picture like this for every market demand graph that we have. We should have hundreds and thousands of individual demand curves kind of at the base and at the starting side, the left side of our market demand schedule to represent all of the individual demands that go into making up that market demand. And we can see here in this picture that if the market demand hit the market supply at a price of 1 or a quantity of 6, what that really is doing is it's signifying to each individual, hey, there is a price of $1. And then each individual is just responding to that setting where there's a price of $1. And that's what their individual demand curve is showing. So Emmett at a price of $1 is going to get a quantity of 0. Lucy is that second line in there. And at that second line in there, it crosses that price at a quantity of 1. Lucy is going to get a quantity of 1. That price crosses for Space Guy at a quantity of 2. And that price of 1 crosses for Batman at a quantity of 3. So following the rule of rational life, going until marginal benefit equals marginal cost. We're just letting people follow their own self-interest in a market setting where we have prices as signals for people to respond to. We end up with people maximizing the total value from the given social resources. In this case, the given social resources were 6 mugs of beer, right? So we do not have anyone in charge of allocating these resources out. The task would be so complicated and so tough for us to figure out who should get how many, right? In a much more complicated picture than just a 4 individual world with these simple demand curves, the task is astronomically challenging. And yet the solution is just as simple as the one that we showed here. Let the price system send a signal and incentivize people to follow their own self-interest, to follow the rule of rational life, and they will make decisions such that we end up with the maximum value of those social resources that we are given. So what we end up with here is the idea that in the standard economic model of supply and demand, demand will be efficient in a market setting. Given 6 cans of beer, there is no way to rearrange them in such a way as to make anyone better off without making someone worse off than the market outcome of people simply responding to exchange and price. In other words, we have Pareto efficiency. You can't arrange them in such a way to make someone better off without making someone worse off. And we also have kaldor-hicks efficiency. The value of social resources is maximized.